Jumping into our physics lessons, we're going to begin with distance and displacement. These two ideas are pretty simple, pretty straightforward, but sometimes students do get the two confused. They sound very similar, they kind of talk about the same things, but they are both different from each other without a doubt. So we got distance, and we have displacement. Distance and displacement. Now let's begin with distance. Distance is a measurable length between 2 points. So a measurable length between 2 points. Now displacement can also be considered a measurable length between 2 points, but the difference here is displacement is going to be the measure from your original position to your new position, which the distance between that can change as you move, which we'll see in a second. And then distance is just the distance between 2 points no matter where those 2 points are. Or it can also be the total measure of all points put together, so a total distance. But displacement, that's going to be the distance, or you could also say measure the distance between an object's original position and new position. So the distance between an object's original and new position. So let's say you go for a walk. And we'll just say you're at point A. Point A could be your house, it could be the school you're at, your workplace. It's just wherever you're originally at before you start walking. And you're going to walk to point B. Maybe point B is the park, maybe it's your friend's house, maybe it's the mall, who knows. So you're at point A, and you go for a walk, you head on over to point B. So you're at point B now. So we'll say from point A to point B, you traveled 2 miles. There's 2 miles between your house and the mall, or your house and the school, but it was 2 miles from point A to point B. So the question here is, what was your displacement? What is your displacement from point A to point B? So, well, you went from point A to point B. The measurable distance between those two from your original position of A to your new position of B was 2 miles. So you have traveled 2 miles. So your displacement is 2 miles, but you could also say the distance you traveled, or your total distance, is also 2 miles. So your distance traveled and your displacement in this particular case is 2 miles. So in this particular example, those two terms represent the same value of 2 miles. So let's say you got done at point B, you got done at the mall, and you want to head to your friend's house. So you travel from point B, you travel up and go to point C. So the distance between point B and point C, we'll say, is 1 mile. And this is not the scale by any means, this is just arbitrary. But we'll say from point B to point C is 1 mile. Well, what is your distance traveled? So your distance traveled from B to C is 1 mile. Pretty simple, right? What about your total distance? Well, your total distance, we'll say from point A to point C, is the summation, or all your points added. So we went from point A to point B at 2 miles, point B to point C at 1 mile. 2 plus 1 is 3, so your total distance traveled right now is 3 miles. Pretty easy to understand. But what about your displacement? Remember, your displacement is your original position to your new position. So my new position is C, my original is A. So our displacement is really the measure between these 2 points, from A to C. Now if you took geometry, you should recognize this as a Pythagorean theorem. So we can use Pythagorean theorem to figure this out. And if you don't remember what that was, a squared plus b squared equals c squared. We have these 2 sides of our triangle. We can use these 2 sides to figure out this unknown side, and we can use that as the distance of our displacement, or the measure of our displacement. So let's try that. So I got a squared plus b squared equals c squared. So we'll say 2 is a, we'll say 1 is b, and this side is c. So I got 2 squared plus 1 squared equals c squared. 2 squared is 4, 1 squared is 1, and we got c squared still. So 4 plus 1 is 5 equals c squared. To get c by itself, we take the square root of both sides. Then we do 5 squared, and we get 2.24, and I am rounding that up, equals c. So the distance from A to C is 2.24 miles. Our current displacement from our original position A to our current position C is 2.24 miles, which is completely different than our total distance traveled. Because remember, our total distance traveled right now is 3 miles, but our displacement from our original position is 2.24 miles. So that, in a quick nutshell, is distance and displacement. So your distance total, if you need a formula, is distance 1 plus distance 2, etc., all the way to however many distances you have. We'll just say distance nth. Then to figure out displacement, you can use Pythagorean theorem for some things. So a squared plus b squared equals c squared. There's also times you can use just a simple formula of displacement equals the final position minus the initial position, or the change in position. So let's say, once again, you're at point A, and you're going to travel to point B. We'll say this is 20 feet. So if you go from A to B, so A to B, your distance is 20 feet. Your displacement is also 20 feet. So the distance you've traveled so far is 20 feet. You went from point A to point B, and the displacement, your original position to your new position, is also 20 feet. Then let's say once you reached point B, you decided to go back. You decided to go back a little bit to point C. Went back to point C. We'll say this was 7 feet. So from A to C now, what is our distance traveled? Well, the distance traveled is just the sum of all the distances. We went 20 feet, we came back another 7 feet, so far we have traveled a total of 27 feet, 20 plus 7. But what about our displacement? So to do that, we went 20 feet forward, we walked backward 7 feet, so 20 minus 7 is 13, so our displacement now is 13 feet. We've traveled overall 27 feet. We went forward, then we came back, but our displacement from our beginning position, from our original position to our new position, is 13 feet, because 20 minus 7. Let's do another problem. And for this problem, we're going to assume these units are to scale and they match. So for instance, this 10 unit length would be the same distance as this 10 unit length, even though the drawing may not be exactly that. We're just going to assume that the drawing is to scale. So what we have is a path that somebody took from point A to point B to C to D to E, and then the units of measure in between. So from point A to point B, it was 10 units. Point D to point E was 8 units. So you could have a series of questions based off this. One example could be, what is the distance traveled? What's the distance traveled from A to D? What's the total distance traveled from A to D? Well, that's simple. To find distance, you just add all your values, all your measurements. So from A to B, we have 10. From B to C, we have another 4. From C to D, we have another 10. So from A to D, it's 10 plus 4 plus 10, which is 24 units. Pretty simple. What about the distance traveled from B to E? What's the total distance traveled from B to E? Well, from B to C, it's 4. C to D, it's 10. And then D to E, it's 8. So 4 plus 10 plus 8 is 22 units. So finding the distance traveled is pretty simple. What about displacement? So let's figure out displacement. So what if the question was what is the displacement from point A to point C? How could we do that? C, we're not measuring the total distance traveled, we're measuring the distance from A to C. So we're measuring this distance, that leg of this right triangle we have produced. So we can use Pythagorean theorem. So A squared plus B squared equals C squared. This will be A, this will be B, and this will be C. 10 squared plus 4 squared equals C squared. 10 squared is 100, 4 squared is 16, and then we got C squared. So 116 equals C squared. To get C, we take the square root. So C is equal to what? Well, the square root of 116 is 10.8, and I did round that up. So that's going to be 10.8 units. So this is 10.8 units for my distance of displacement. Well, what about from A to D? How do we do that one? We know we're going to use Pythagorean theorem, but how? So from A to D, we went this pathway, but we need to know from here all the way over to here. What we can do is extend this line out because we know this distance. We know this to be 10 units. Then we need to know what's the length of this side. Well, the length of this side should match the length of this side. So if this one is 4, then this one should also be 4. So now we can do a little bit of math. So we got Pythagorean theorem. So we'll say this is side A. 10 and 10 make a total of 20. That's going to be squared. B, we'll say this one's B. That's going to be 4 units. That's going to be squared. And then we're looking for C. So 20 squared is 400. plus 16 equals c squared. So that's going to be 416 equals c squared. To find c, we take the square root of both sides. So the square root of 416 is 20.4, and I did round. So it's going to be 20.4 units. So this distance of displacement here is going to be 20.4 units. And you can do that with pretty much any question this problem may ask. So if we wanted to figure out what's the displacement from A to E, we could do the same thing. From A to E, we could finish out this side, which would be 20 units. And we'd be trying to figure out the distance of displacement for this particular line here. So we would need to know, what is this segment? Well, if the total length is 8, and this portion is 4, and this portion is also 4, because 8 minus 4 is 4. Then you can stick those values into Pythagorean theorem and figure it out as well. So just a quick little recap. Distance is just a measurable length between 2 points. So the length between A to B is the distance. The length between B and C is the distance. The length between A to C is all those points added together. So A to B plus B to C. So distance, you just added up. Displacement is the distance between your original object's position and your new position, so in this case C. And to do that, we just do Pythagorean theorem, and in some cases, if it's on just a straight line kind of deal, we can just add and subtract like we did on this problem. But the value for distance and the value for displacement won't always be the same, like on this problem we did at the beginning. So just watch out for that and pay attention to those differences. But displacement and distance can share the same value, however. Like if we went from point A to point B, the distance is 10, but also the displacement. If we went from point A to point B, the distance is 2. But if we did the displacement from A to B, it is also 2. So it can share the same value, but a lot of times it won't share the same value. So just pay attention to when it does and when it doesn't. And I hope this video helps. And as always, good luck on those tests.